All right, now we're going to change our script so we can move our object around, because that's mostly what you want to do in games, right? All right, so here's our script that we have currently. I'm going to not erase, just comment these out. I have them there for examples for later or something like that. Now, should we put the movement in the start or in the update? Well, we want it to happen over and over again, so we're going to put it in the update. Okay. But let's first look at a little how you get movement in, or how you get the placement in Unity. So here's our sprite object, and the transform. Every object has a transform. Position will set its place. So so as I can pick it up. This is the move goodie. So click on there, and when you click on, when it's active, you'll see the arrows. All right. So this is the Y and this is the X. And for 2D, the Z comes out looking at you, but for 2D there is no Z position. So you always want to leave that at 0. So we could manually do this, right? And as we change it a little bit, we can see it move down the screen. You know, as it moves a little bit by little bit. Or we can also, when you have this clicked, you can actually pick it up and move it. There we go. Pick it up and move it around. Okay. So that will create if we change that a little bit by little bit, that will change it. So that was in the transform. So it's going to say go to the transform of this object. All right, and we're going to use a function called translate. Translate changes that position a little bit each time. Translate, because there's 3, X, Y, and Z, even though we're in a 2D game, we're not using Z, but they always have them in there, takes 3 parameters. So first the X, the Y, the Z. And this is how much it's going to change it by each time. That's what translate does. So I'm going to put a little number in here. So 0.5, and in Unity, it wants float numbers. So those are, we put a little F to tell it that it's a float number, floating decimal. And I'm going to not change it in the Y right now, and I do not want to change it in the Z. You can, it won't matter, you won't see it because it's a 2D game. So now we go File, and we save, and then we go back, and we run. There it goes. All right. Well, actually, it goes pretty fast, huh? I thought that was a small number, but it's not that small. So I'm going to go back and change that to there. And what if I also change the Y a little bit? So now, what is it going to do? Can't get that 0 out of there. There we go. Now, will it take just 2 numbers? No. Even though we're only changing X and Y, we have to put all 3 in. All right. There we go. And see, it goes a little bit up and a little bit over. Over and over again, updating. All right. Now, let me turn it off. Now I want to rotate it. Okay, so rotation in a 2D game is, so this Z is coming out at us, right? So rotation is really just around the Z axis. So there is no X and Y rotation in a 2D game. So like I could put degrees in here and you'll see that it rotates, right? All right. So one way is positive, the other way is negative. Now, this is also a little rotation tool. So you can click on there and you can click and drag and you can rotate around to see things rotate. All right. So we got a move tool, we got a rotation tool. All right. So let's put some code in here to make it rotate. So that rotate was also in the transform. So transform and then the dot to say I want to get to a function, right? We've done this before. Rotate. And it also takes 3 numbers, but we're not going to do anything to the x and the y. And then we'll put in a floating decimal for the rotate, floating decimal, but it's still going to be, it's in degrees, right? So let's move it 5 degrees. We still need the F. All right. So now it should be moving up and rotating at the same time. File save. And run. And there it goes. Because it's rotating it, it's moving up, but it's moving back down because it's rotating. Now, let's think about scale. This is sort of big, right? So we can't, again, we can't scale it on the Z for a 2G game, but we could, make it smaller in the X. We could make it smaller. If you want it to say keep proportional, you need to change the X and the Y the same. If you want to stretch, you can change. And again, there's a tool. So we can do the scale with a tool there. See, and you can see the numbers. If you get something you like, and then you can go, oh, that's 0.7, whatever. The scale is 1 is a multiple factor. So 1 is original size on both. And then if you want it double, you would times by 2, so 2 on both. If you want it half, you would times by 0.5. 0.5 on both will give you half. All right, so let's do a scale. Now, scale is a little bit different in than the other two. It's not quite as easy, but it's still a transform. All right, and then we need to get to a variable called local scale. And look, see, when I start to type things in, it gives me some help, so I can just go like that if I want. And then the local scale adds. All these things are vector 3s, but the other two sort of hide them for us, that they're still in there. We're going to add to the vector 3, so we've got to go equals plus, or plus equals, to add to it each time. You guys have seen that before. New vector 3. And a vector 3, of course, takes 3 things. All right. And so I'm going to make a little scale change on the X. And a little scale change on the Y, and none on the Z, and let's save, and run. And see, the scale's going up a little bit each time as it's rotating, and bigger 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 and bigger. And we're in a forever loop, so it will do it forever until I pause or stop. All right, that's your first moving